So, for number one, I'm gonna do these in a specific order, and there's a reason for the order that I'm doing, and we're gonna learn that like right when we start the lesson, okay? But for right now, just kind of go with it. So remember, like terms are when you have the same letter and the same exponent. So which ones would be like terms, like one set? Yeah, so the 3x squared and the negative 2x squared, right? So what's 3x squared minus 2x squared? Yep, just 1x squared or just x squared. No. So when you're adding and subtracting the, since they have to be like terms, you just keep the answer also like terms with them. And then we also have negative 4x and negative 5x. What's that going to make? Yep, negative 9x. That's it. No, because these two aren't like terms, so you can't combine them. Like this one would also have to have an x squared in order to combine them. Does that make sense?
Yeah.
Okay. Yeah, if that was x squared minus 9x squared, then it would be negative 8x squared, yeah. All right, number two. So the ones with the variables, we have a negative 2d and a positive 5d. What's that going to make? Yep, 3d. And then for the just plain numbers, we have a 7 and an 8. What's that going to make? Yep. You can't. Because one has a d and one doesn't. Does that make sense? Okay. Next one. So anytime you see parentheses, you should be thinking distributive property. Okay? So we're going to distribute that 3 to start. So what's 3 times 2r? Yep, 6r. 3 times 4r squared. So plus 12r squared. 3 times negative 7r. 3 times 4r squared. Okay, we all good so far on that? Okay, then like terms. So I'm going to do the r squareds first. So I have 12r squared and 12r squared. What's that make? Yep, 24r squared. And then I have positive 6r with negative 21r. Yep, negative 15r. That's it. Good? Okay, next one we have two sets of parentheses, so we're distributing two things. So first distribute the negative 2. So what's negative 2 times m? Negative 2m. Negative 2 times 1? And then distribute the positive 9. 9 times 4m. 36m. 9 times negative 3. So now combine like terms. So I have negative 2m and positive 36m to make what? Yep, 34m. And then I have negative 2 and negative 27 to make what? Yep, negative 29. Are we good up to this point? Yeah? Okay. Next one, same thing as just distributive property. 6 times a is what? Okay. 6 times a? 6a. 6 times negative 3a squared. Negative 18a squared. 6 times negative 2a. 6 times negative 3a squared. And then combine like terms, so I'm going to do negative 18a squared and negative 18a squared. What's that going to make? So they're both negative. Yeah, negative 36a squared. And we have a positive 6a with a negative 12a. Yep, negative 6a. All right. Last one's a little bit tricky because when you go to the parentheses and look in front of it, you don't really have a number there. So what we're going to basically do is we're going to act as if this subtraction sign is basically a -1 getting distributed. Okay? So let's bring down the s minus 4. And we have -1 times s squared, which is what? Negative s squared. Then -1 times -2. Yep, positive 2. And bring down the minus 8s. So are we all clear on how we did that? The subtraction in front of the parentheses just distributed it.
Yes.
All right, so now I have just negative s squared with nobody. So just bring that down, negative s squared. I have an s and a negative 8s. What's that going to make? Yep, negative 7s. And then I have a -4 and a positive 2. -2. Yep. All right. Are we all clear? All right. Objective is students will be able to classify, add, and subtract polynomials. It's going to be a little bit of like math vocab, a lot compared to how we normally are, but. All right, so first off, a polynomial is, since it's in the title, what does the prefix poly mean? Yep, so usually many, okay? So polynomial literally means many terms, okay? And then, let me think. Okay, so the degree you're going to be asked for quite a bit. So the degree of a polynomial is whatever the highest exponent of that polynomial is. So on like our answer to this last one, this would have a degree of 2 because the highest exponent is 2. Does that make sense? Yes? Okay. The only time that changes is if you have a situation kind of like this where your expression has like 2 different letters. Then you would go and you would take the highest from each letter and add them together. Okay? And then standard form is the order that you need to write every answer in from now on. So all year, you guys have been kind of asking, like, does it have to be in that order? Is it okay if it's in this order kind of thing? And I've been like, well, eventually it's going to matter what order, but it doesn't right this second. So it's up to you if you want to, like, get in the habit of it now. Now we're kind of at that point. So standard form is whenever it's written from biggest exponent to smallest exponent. And all of your answers have to be written in that form from now on, okay? So that's why whenever we were doing the warm-up, I was going in like a very specific order of like which ones I wanted to combine first so that I knew I just went in order from biggest exponent down to none, okay? Yeah. Okay, so let's just practice with degree so that these are just monomials. So remember, degree is just your highest exponent for the variable. So for a, we just have 5x. So what would the highest variable exponent be? Just 1. Yep, because it's x to the first power. For b, we have 2 different letters, though. So what would be the highest for x? 3. And then for y? 2. And then you have to add those together. Yep, so 5. So highest of each letter added together if you have more than one letter. Okay? And what about C? Zero. Because there's no variable. And the degree is like the highest variable exponent. Okay? Yeah. Okay, go ahead and try the next ones. Okay, we good? All right, what's the first one? Yep, 2. So remember, both of those have 1s. What about B? Yep. And then C. Yep. Okay, so now moving on to just some are different, just adding or subtracting just 2 things together. So remember, they have to be like terms, and you keep the same like stuff, like term stuff. Okay. So for A, 3x squared plus 5x squared, just add the 3 and the 5. Yeah, 8 is just me 8x squared. Good. Because they have to be like terms to be able to add or subtract. Multiplication and division, you can do whatever you want. So like when we're multiplying, we add up the exponents. When we're dividing, we subtract the exponents, all those Unit 7 rules. But with addition, subtraction, they have to be like terms, and you just keep it all the same. Yeah. Okay, for B, what would that one be? 3x cubed y. Because the second one counts as one of them. So minus 1, basically. So you're only really doing anything to the numbers in front of the variables on here. Okay? You guys try the next ones? All right, what do you guys get for A? Yep, 5x to the 4th. What about B? Yep, negative 5, x squared, y to the 4th. Do you have any questions before we move on? Okay. All right, so now we're going to look at how we name them. So all of our polynomials have 2 names that kind of go together to like actually name it. The first name comes from the degree. So remember the highest exponent that you have. So whatever the highest exponent is, that's going to give you your like adjective part of the name. So it's either going to be constant, linear, quadratic, cubic, quartic, or quintic. And then how many terms you have, so how many pieces in the problem, is going to tell you if it's a monomial, binomial, trinomial, or you just say polynomial after that. Okay? As far as like remembering this / like people have been asking if they have to memorize it or how that works. So I would say honestly, guys, that like these words are going to be so normal to us starting now, and we're going to be saying all of this so much that I need you to just like have it memorized. I need you to just know what I'm saying when I say it. Okay? And you guys are going to be using these words so much too, it just becomes second nature. So you just have to like just learn it. Okay? Learn these words. A way to kind of like the number of terms is really easy to remember, like monomial, binomial, trinomial. They're like prefixes you guys recognize, right? Over here on the degree side, there's a few that are kind of like trickier, but try to just like remember the ones you can, and then like you'll only have to actually like put effort into memorizing a couple. So like constant is a degree of 0. So basically just a number, like 4. So do we understand like why a variable is called a variable? Or not really? Do we know what it means to be variable or to vary? Yeah, so basically to change, right? So a variable is called a variable because like it depends on what number you're plugging in for it. It's going to change the value. So numbers that don't have variables, like just 4, they're called constants because the value stays constant because there's nothing that's going to change the value of it. Okay, so whenever you have a degree of 0, which is basically just a plain number with no variable, it's called constant because the value doesn't change. Degree of 1, so like x to the first power, is linear. So the way I remember that one is with our formula, y equals mx plus b. What does y equals mx plus b make? Like on a graph. Yeah, but like what kind of shape?
Line.
Yep, a line. So it's linear. It makes a straight line, and it's x to the first power. The highest exponent is just a 1. Okay? Cubic is pretty easy to remember. I feel like you guys like to associate cubic with 3 already. The ones that people get messed up on are quadratic and quartic because a lot of people say that like quadratic to them means 4, but in this case it's 2. So just remember quart, like there's 4 quarts in a gallon, there's 4 quarters in a dollar. So everything having to do with 4 is like quarts. Okay? Yes? Okay. And quadratic, we're going to say that word probably a bajillion times in the next couple weeks. So like you'll just have to know that word. Okay? So here's what it's going to look like when you name them. So first you're going to write it in standard form, which remember is biggest exponent down to none. And then you're going to find the 2 words that work to put it together. So we have 3x plus 4x squared. So when I put it in standard form, which one should I go with first? Which one has the bigger exponent? 4x squared, right? So that one should go first in order, 4x squared plus 3x. So that's your standard form. Biggest exponent down to smallest. Okay, so then you need to find the degree and the number of terms. So what's the degree for this one? Remember, what's degree? Well, the definition's on the next page before this. Yes, so well, the degree isn't 3. Because remember, you only add if it's 2 different letters. So what's the highest exponent? 2, so that's your degree. Okay? And then number of terms is like how many pieces do you have in that problem? 2. So a degree of 2 gives us the word quadratic. And 2 terms gives us what? Binomial, yep. So this is a quadratic binomial. Okay, next one. So we have to put that one in standard form also. So which one should go first for standard form? Yeah, 5x to the third. Okay, then what?
Can you add?
Uh-huh. Yeah, combine them together.
11x.
Yep, so plus 11x. And then what? Minus 1. Mm-hmm. So if you can combine like terms as you're doing that, then do it. Okay? So now, degree is what? 3, yep. And number of terms is what? 3. So a degree of 3, what? You do. It's like 1, 2, 3. Yeah, so terms are separated by addition, subtraction signs if you're having trouble counting them, okay? So a degree of 3 gives us what word? Yep, cubic. And what about 3 terms? Trinomial. Okay, good? Okay, try that next one. So what did you guys put in first for standard form? Yep, 8x squared plus 2x minus 3.
Can you not add them? It has exponents.
Correct. Yeah, so it has to have the same letter and same exponent to be able to combine. Okay, so what is the degree for this one? 2. And then how many terms? 3. So this would be what? Quadratic trinomial. All right. Do we feel okay on that? Okay, the only thing left is just like adding and subtracting like bigger ones. So for example 4, you have a researcher that just kind of has been tallying the number of overnight stays in campgrounds and in the backcountry. So it's asking what polynomial models the total number of overnight stays in both campgrounds and backcountry. So what is it asking us to do with those two things? Like if you're finding the total, add them. Yep. So just basically like combine like terms, same thing. They're just written vertically. So what's negative 7.1x squared plus 21x squared? Yeah, so 13.9x squared. Okay, then we have negative 180x and negative 140x. Yep, negative 320x. Well, you are subtracting, but when you subtract things that, like, they end up having the same sign, so they just get bigger negative. Does that make sense? Okay. And then what about 5,800 plus 1,900? 7,700? Okay, so 7,700. Okay. Okay. There's that. Does that make sense? Like, don't overcomplicate this because it starts off really, really slow. So it's like if you're like, this makes too much sense. Like I feel like I'm supposed to do something else after that. It just rolls it. Okay. All right. So you guys try that one. This one, yeah. Yeah, I just wrote the answer in the next one. So only combine the ones that have the same exponents. If it doesn't have a buddy, just bring it down. Okay, am I good to do it? Yeah? Okay. So for this one, you're adding these polynomials up as well. What is the highest exponent? 3. Does this 3 have another buddy to add with? No, so just keep that negative 12x to the third. All right, next highest exponent would be what? 2. Yeah, so we have 106x squared and 14x squared. So what's that going to be? Yeah, 120. Yeah. So plus 120x squared. that make sense? Just gonna circle these. Okay, and then the next one is just the x's. So which ones are those? Yep, and so it's the word that's going to act as a negative 241, and that's going to act as a negative 14x. Okay? So negative what? Yeah, so negative 255x. Okay, and then your constants, we have 4477 and 1545. 6022? Yep. That's it.
Wait, so that's the second equation, not a problem.
It is. That's what was asking us to do this. I just like put it in wrong spot, so I'm both. So. Yeah, no, the first one's actually not asking us anything. It's just saying that like these are the results from when the nutritionist did it. But yeah. Okay, last thing that we are doing is subtraction. Just focusing on that. So a lot of times subtraction can be tricky and like lots of mistakes get made because when we're like first going into the problem, we see it's subtraction, we start subtracting, but then like halfway through that like list and line, you kind of forget that you're subtracting and you just start combining like terms and then it ends up wrong, okay? So what I like to do is when I have a subtraction problem, so the negative's in the middle, I kind of pretend like that is a minus 1 in front that's being distributed to that second group. So basically applying the sign change for subtraction to everything at once so that you don't have to worry about it later, okay? So here's what it would look like. Okay, so I usually bring down my whole first one. So x to the third minus 3x squared plus 5x. And then as I distribute and I get like my answers here, I'm going to put those answers underneath the like term of that one just to like kind of organize it, okay? You don't have to do this, but I just like to. So what is, negative 1 times 7x to the third. Yep, negative 7x to the third, so I'm going to put that under the x to the thirds I already have. So negative 7x to the third. Oops. Okay, and then negative 1 times 5x squared. Yep, negative 5x squared. And then negative 1 times negative 12. 12, yep. So we don't have a plain x, so I'm going to just do there. And then you can basically just go straight down, add it all up. So what is x cubed minus 7x cubed? Yep, negative 6x cubed. Negative 3x squared, negative 5x squared. Yep, negative 8x squared. Bring down the plus 5x. Bring down the plus 12. You're just doing whatever the sign is. So technically I'm adding, but since it's a negative, it's kind of like subtracting. You're just doing whatever like the sign of the number is. Because it's a positive 1 minus 7. Does that make sense? Okay. Or positive 1 adding to negative 7. Same thing. Can you guys try this one? So take the negative and apply it to the second set, and then combine like terms. Am I good to do it or not yet? Yes, no. Yeah. Okay, so I'm gonna bring down that whole first one. So when I do this also, if there's an exponent that I'm missing that I might have in the other one, I kind of leave a gap, okay? So negative 4m to the third minus m plus 9. Nope, no, wait. I'm going to rewrite this to look like this. Negative 4m to the third, I'm going to leave a space, minus m plus 9. For like anything that has an m squared has a little spot, okay? Okay, so now take this negative and distribute this to everything. So it's negative times 4m squared. Yep, negative 4m squared. Negative times m. Negative m. Negative times negative 12. Yep, positive 12. Just bring them down. Yeah, so you just can bring down negative 4m to the third minus 4m squared. And then combine these. What's negative 1 and negative 1? They're the same. Yeah, negative 2. Because like negative 1, negative 1. And then 9 and 12? Mm-hmm. I think there's no. Any questions on this? Anything? Okay, go ahead and do the lesson check. Are we done with the lesson check? Yes, no? Okay. What do you guys get for number 1? What's the degree? 4, yep. What about number 2? 5. Okay, 3 is addition, so what do you guys get for that one? Yep, 11r to the third, plus 11. 4 subtraction, what do you guys get on that one? X squared minus 3x minus 7, yep. Okay, and then naming 5 and 6. So what's 5? A quadratic, what? Yep, trinomial. Okay, what about 6? Huh? No constants if there's no variable at all. Remember y equals mx plus b. Linear, yep. Say linear what? Binomial, yep. Questions?